Alright, this is a walkthrough of lab number 24. We'll be taking a look at models of the atom. I know you've seen a lot of this lab in the lecture, but if you can't get the Java lab to work, then I'm going to work my way through the lab, and it's up to you to jot down your findings. So we're going to open up this simulation right here, and I've already had it up and running for a little bit because I wanted to build up some statistics. What can we do is we can turn this light on and off, and we can mess around with the color of this light. What we're supposed to be paying attention to is we're supposed to be paying attention to what's coming out of this box, and we're bombarding it with white light. White light is all of the colors of light combined. So these are the little photons right here, and we can see once in a while one comes squirting out of this box. There was one right here, and there was one right there. What we're tracking is we're tracking the colors. That's what the spectrometer right here does. And I've had it running for a while, so you can see we had lots of UV come out, and we're seeing only specific colors come out of this box. So that's going to be your observations, and it's probably an indication of what's hiding inside of that box. Now we're going to go ahead and take a tour of history here, and we're going to say how would the various models of the atom as we progress through the years interact with light. So first we're going to go to the billiard ball model, and this model right here has the light, or has the atom right here, and you can kind of see that all light of any color randomly just kind of bounces off that, and we know that's not actually what happens. So what we're going to then do is we're going to take a look at J.J. Thomson's plum pudding model. And this one right here is going to look like this, and pay attention to what happens when light interacts with the atom. You see the proton, you see the we don't really see neutrons, and you see the electron, and you can kind of see that only one color comes off of this light, or only one color comes off of this atom of hydrogen, and we know that's not what happens. Now what we can do is we can take a look at the Bohr model, which is the more standard model, and this guy right here has the electron living in orbits, and what we can do is we can say this better explains what's going on. We're going to see certain colors, and these, as these statistics build up, would be the same colors that we observed with the reality, and they correspond to the jumps that the electron makes. You can see the electron can jump out here, and then it jumps back. It emits a photon of a certain color when it does that, and it can go up here, jump down, and so on and so forth. So we're starting to build up the picture that we saw initially with this particular lab. Last, we were going to take a look at the Broglie model, and with this model right here, what we can do is we can say, well, the electron is now going to behave like a standing wave, and this better explains what's going on. It explains why we have these discrete orbits. I will note that the orbits are not symmetrical. They're not evenly spaced as depicted in this particular representation. They actually get closer and closer together, as you will see in one of the other labs that you do. Something else to kind of bear in mind is we could also change our view, and we live in a three-dimensional world, so not only could the wave be going in the radial direction as we showed, but it could also be doing this weird funky up and down type of thing. If we were to look at a different view, you can kind of see we would have the up and down and side to side motion all occurring at once. It still has to form a standing wave.